Hello, and welcome to E3D's Unreal Materials, an Introduction and Application. And through this DVD, we're going to be going through a lot of the common nodes and kind of giving a base foundation on what these nodes mean and how they can be used in different ways. And after we get through with that, we're going to go through several real-world examples. And what you see here is a scene I had quickly put together with BSP. It is in no way represents a real environment, but it's just something to quickly show these materials on some kind of surface with some kind of basic lighting. And this scene is going to come with the DVD, and you could see a couple of different things that I chose to do here with showing these materials off. And you can see we have places where we have placed some rubble that we're going to be going through making. And for the rubble, we will be going into Max and explaining how a modular set of these could be used, and then how the shader could help sell these looking so unique by just sharing the same textures. And the window, you can see here how we can see into the interior, but it's just a flat surface. So if I show you here, these are just flat BSP surfaces. And if I turn off textures, it's very, very simple. And you can see here with the brick wall, it's just a tile brick. We have a couple things here showing off displacement, and we have the brick being broken up by a rock texture. We have this ground with some stain decals everywhere. And really, there are several things we're going to go through, but a few interesting things are these textures will be free for you to use in your project, whatever that may be. There's no restrictions like there were on the old damaged pillar, so you can pretty much use these textures for whatever you want, and you could use these shaders for whatever you want. And the video really starts off with very basic understanding of Unreal materials and the nodes, and anyone should be able to pick that up and get a grasp or understanding of what those mean. So any beginner should gain a lot from this. And as I get into more of the complicated materials, even a lot of professionals can help understand how to create these shaders from scratch. Or if you have to go in behind someone else and fix some of their materials or optimize some of their materials, you'll have a good understanding on how you might be able to do that. This is more geared toward beginner to intermediate, and maybe in the future I hope to do an advanced one to where all this foundation is laid so we can go into really complex materials and shaders and how to do some more interesting things. But I think most people will get a lot of valuable information out of this, and they should be able to incorporate this into any mod or any game or any personal work to show off even normal 3D models. I've used Unreal in the past just to show off some of my personal work because I like the renderer, I like the lighting, and it's a good way to quickly get something in there and make it look nice. And you can see here how I've even placed some of these pieces around large so you can see different uses of these things. And even these decals, you could see how they can really break up 90-degree angles. And since this whole map is 90-degree angles, it helps it. But like I said, this is just a very simple test scene. But I have added some lighting, post-processes, and stuff like that. So if you wanted to poke around in this scene and try to figure out all the little things, then I would encourage that. And if you have any ideas, suggestions, or feedback, just post on the E3D forums and I will gladly answer any of it. So hopefully you'll get a lot out of this. This is something I wish I would have had a couple years ago, and I think most people will benefit from it greatly. I really appreciate you purchasing this video, and I hope you continue to support our efforts as we strive to make the highest quality training for next-gen video games possible. Thanks.
Okay, in this first section, I'm going to go through each one of the material nodes that are going to be used throughout the video. And I'll just give a brief introduction to each one of the nodes so we can help understand their purpose, and hopefully it'll avoid confusion later on. And to do that, I'm going to be using the Unreal Editor 3 that comes with Unreal Tournament 3. When you first launch the editor, it'll open up a generic browser, which is this window here, and the actual editor itself. So in the generic browser, the first thing we need to do is create a new material in its own package. So to do that, we'll right click in this open area and we'll say new material. And we want to put it in its own package. So we'll give the package a name. And to organize it, we'll keep things in groups. So we'll put this in the material group. And we'll name the material itself. And then we'll hit OK. And what it's going to do is going to automatically open up the material editor. And I'll just resize it. And the first thing you'll see this black window here, which is really supposed to be a 3D representation of the shader. Or this is supposed to be a 3D view window. But since there's nothing plugged in, it's just rendering black. And this is going to be the work area where we will be placing our nodes and connecting them to create various effects. And over here to the right, this is a list of all the nodes that we have available to us. And at the bottom here we'll have the properties for whatever we have selected. So if we have a node selected, these will be the properties. Or the whole shader itself has these properties. There are some buttons up here I'll go over a little bit later. And the first thing we want to do to demonstrate is texture sample node. It's probably the most common, most important, and it's a way that we can use a texture in our material. So we'll scroll down here and we'll just click texture sample and drag it into the scene. Another way to do that is you can right click, but I won't be using that because it goes off of the display screen. And to move this node around, if you just click and drag, it'll move the window, but you actually have to hold down Control and select and drag it to move it around. Now we need to plug a texture in here, so to do that, we'll select the node, and then these are its properties. So we have texture. This is where we'll plug in a texture. And to do that, we need to go back to the generic browser. Quick way to do that is to click this magnifying glass. It opens a generic browser. Then we'll go down to the package we made, which was called Shader Tutorial 01. And we will go ahead and save this package. Now we're going to import a texture so we can plug that in. So we'll go File, Import. And we'll import this black and white squares. And we'll put this one in a texture group. And hit OK. So here you see it brought in the black and white texture, and we will save the package again. So now what we need to do is select that texture and then go back to the shader. And with that selected, we can go in here and select this green box, this green arrow, that will plug that into that node. So now you'll see these colorful dots here. Black is going to use R, G, B, and A, all the 4 channels, if you plug that in there. Or if you wanted to, you could just plug in the red, the green, the blue, or if you have an alpha channel in there. But since it's black and white, all these 3 are going to be the same, and we don't have an alpha. So for now, we're just going to plug in the diffuse, this black dot into the diffuse. And you'll see it just put it on here, very plain. No specular, no highlights, no normal maps. And that is pretty much the value of a texture node. And one other thing down here, you see a description. Every node is going to have this description, and we can just sometimes it can help with organization, or if somebody comes back and looks at your material to figure out what you did or to update it, it can be a good idea to give it some kind of description. So for now, I'll just put diffuse. You can see it placed it up here. And that doesn't do anything but just places text for visual notes. So the next node I want to go over is a constant. Constant is it's a very common, very straightforward node. It basically just has one value, and it's a numerical value. It's just one channel. It represents, it says an R here, so it represents just one channel. It represents one color, one pixel, pretty much. So in here we can plug this into the diffuse, and since the value is 0, it's like a black pixel. So if we put in 0.5, it should be gray, exactly half between black and white, and 1 would be white. So this is just a single value, and you can use this to control all kinds of things. So to break this link, you can drag something else over it, which will break the link. Or another way to do that is to hold down Alt and select either one of these, and that will break the link. Or you can right click on it and say break link. And that's pretty much a constant. The next thing I want to show is an add. An add will basically just add the values of two different inputs. So right here we have a texture and a constant. So if we plug the texture into A and the constant into B, it's going to add a value of 1 to every value in here. So if you want to see what it did, you can click this little box here, which is real-time preview. And we plug that into diffuse. And so you can see what it did. It added a value of 1 to everything here. So the black was 0. That's the pixel value. So now it's 1. And the white was 1. So now it's 2. So this way it will brighten up your darks and it'll brighten up your brights. So this is just like a force add over everything. And that's pretty much just an add. It's very straightforward. So the next thing I want to go over is a multiply. And add is pretty much like a screen in Photoshop, and a multiply is like a multiply in Photoshop. So if we do the same thing, we'll plug the diffuse into A and the constant into B. You'll notice with real time on that it didn't do anything at all. Plug that into diffuse. So if you plug the diffuse into diffuse and then this multiply back in, you'll notice there's absolutely no change. That's because anytime you multiply something by 1, it stays the same. So if we put this at 0, it'll be like in math, if you multiply something by 0, it makes it 0. So it's solid black everything. But the good thing about a multiply is if I punch in like 2 in the constant, you'll notice that it leaves the darks fairly dark. And the reason it does that is because, you know, those values are 0 already, so you can't multiply anything by 0 and have it change. But the bright you can. So basically this will keep the darks dark, and it'll bring up the whites, the lights. And multiply is very common, very useful node. So we went over the add and the multiply, and we will go ahead and delete these for now. And the next thing I wanted to show was a 1- node. And a 1- is very straightforward. All it does is invert your texture. So whatever values that were there, it's just going to invert it to the opposite. So if the value is 0, it's going to be 1. If the value is 1, it's going to be 0. So it's just like a invert in Photoshop. we'll be using that later on. And I'll go ahead and delete it. And the next one I want to go over is a power. And a power is basically just like a contrast in Photoshop. So if you plug that in, you'll notice that it's a little hard to tell with this. But if I go down to like 0.5, you'll notice, or 0.1, you'll notice that it just starts taking the contrast of this down, the power of the pixels themselves. So put it like 5 or 10, you'll notice it gets very sharp around these edges here. And it starts to really bring those values closer to an absolute value. Like instead of having many variations in the gradients, it's just going to start making them black and white or solid values. So that's a power. You can think power, you can think contrast. So I'll delete that one. And then we'll go over a clamp. So you have a clamp node, and the clamp is basically going to limit the ranges of whatever you plugged into it. So sometimes you can have a long string of nodes connected to each other, but sometimes the ranges can get a little, you can get some artifacts or things can get out of control, and you just need to clamp things so it prevents those kind of distortions or artifacts. And to show that effectively, I will just pull out a couple constants and I'll plug the value. This is the value, and then this is what the clamp values would be. So you can plug a texture or anything in this top, and I'll give this constant a value of 5, and we'll plug that into the fuse. And you'll notice it's not clamping in it because we haven't given any information. It's just going to be a value of 5. But if we have this other constant down here, and let's say we want to make this to be a maximum of 1, so we'll plug that into the max, and you notice it took it down to 1. So it doesn't matter what this number is, it's going to take it back down to 1. Or if we give it like a 7, it's going to leave it at 5 because it never reached that maximum. Same thing with minimum. It's going to clamp that value as well. So let's say we wanted the minimum to be 1, and we had this at 0. You'll notice that even though this is a 0 value, which is solid black, the minimum is increasing it to 1 because that's the minimum value we set it. So we'll be using clamp a little bit, and I just wanted to give a little introduction on clamp. And also there's this constant clamp, which is exactly the same thing, except when you plug that in there, you'll notice you don't have any inputs for constants. Instead, they're built in down here in the properties. So if we set that min back to 1, it does the same thing we just talked about. And the reason why you may want to use constants as external nodes to control those is sometimes you may want to interact with it in scripting, or with you want to reuse other nodes that you've already been using. And so sometimes you may want to use it. But if you're just going to want to do a basic clamp, a constant clamp is best. And that's pretty much a clamp. So for now, I'll delete it. And the constant, you'll see, like I said, was a 1 value. But alternatively, we have a constant 3 vector. So it's very similar to a constant, except it has the 3 values like a texture would have. You have an R, a G, and a B. So if you wanted it to be red, a 1 would be red, and you can see here. Or you can give a bunch of different numbers to give it, interesting colors for tints or whatever. So to demonstrate this a little bit, we can put down an add and just add this color to our texture. And you'll see that it added that color value to everything. And this constant 3 is very, very good, very useful node. We'll be using it a lot. Another node is a texture coordinate. And a texture coordinate, you see down here, it'll let you tile the texture along whatever UV range you give it. So if we plug this in, it's not going to do anything until you tell it how much you want to tile. So we tile 2 in the U, you'll notice it just tiled it that way, horizontally. Or if we tile 2 in the V, it goes up. So that's how you would tile textures along a surface. Also, if you look in here, you have a coordinate index, and this is where if you have multiple UVs on your static mesh, you can have you can change this to 1 for it to look for a second UV, or 2 to look for the third UV, and so on. So this can be really good if you want to multiply an ambient occlusion that has a second UV set over the top of your textures. And we will be going over that. So I'll delete that. So the next node I want to go over is a linear interpolate, otherwise known as a LERP. And what a LERP does is it basically lets you blend between two inputs based on an alpha. So to demonstrate that, I'm going to delete this add, and I'm going to make 2 constant 3 vectors. So if I wanted to copy that, I can hit Control C and Control V, and it'll copy that out. And I'll change this to a greenish color and plug them into the inputs. And I'll use the diffuse, this black and white, to put into the alpha and put this into the diffuse. And you'll see that it gives you this error, and the reason it gives you this error is because anytime you have alpha inputs, it wants a single 8-bit value, and whenever you plug in the black dot into the alpha, it's trying to use all 3 or all 4. So basically we just need to, and since this is a black and white, it doesn't matter. You can pick R, G, or B. So if you pick R, it's just going to give these values that you see here. So everywhere that was black, it put this reddish orange color, and everywhere is white, it put the green. It's very useful. You can maybe put grass at the bottom of a rock, and then the rock in the middle, and maybe some snow at the top. It's a good way to blend tiling textures, or not just textures, you can blend anything. Okay, so that's a linear interpolate. We'll be using that one a lot. So I'll delete that. And now we have a texture sample, a constant 3, and a constant. And I would like to show there's another version of these 3 nodes that have one extra parameter. So for the texture sample, if you look down, you also have a texture sample 2D, and the reason it brought this texture in because it's still selected in my generic browser. But you can see the only difference between these two is it has this parameter name value, and this is where you can be able to talk to it with Kismet or with material instances, or maybe other ways. And to demonstrate that, I'll put diffuse in here. But it's different than a description. Description is purely for visual reference, but the parameter name is actually a value that's stored inside that node. So you only want to use this whenever you want to interact with it some way externally, outside of this material, because it is a little bit of overhead. If you don't want to do it, don't use it. But similarly, for this constant, you have a vector parameter. It's also the same thing as the constant 3, except it has a parameter name. But another thing that's unique about a vector parameter is it has this little color picker instead of just using numeric values. So if you click the magnifying glass, you can actually just choose a color visually instead of typing in numbers. So that can be convenient when you're just doing some experiments, but it does add that overhead of the parameter value. So as tempting as it could be, maybe you could just have one out you're using to figure out these numbers, and you'll end up plugging them into here. And for this one, we'll name it color, the parameter name. And the same thing with a constant, you have a scalar parameter. And it's the very same thing, except it has this. And we'll name this one spec. And we'll plug these in. So plug this one into the diffuse. We'll plug the scalar parameter into the spec. And we'll give it a value of 1. We can see a spec. And we will move these to the side. And we will add this diffuse to the blue vector parameter. And plug that into the diffuse. So now we have these three parameters that we can change externally. And before I get too far, I want to explain these green checkboxes. And basically, you need to check this first green box if you ever want to save any of these changes you did inside this window. None of this has actually happened yet, and until you hit that green button, you could lose all your work. So hit that green button a lot. And even if you save your package, if you didn't check that box, it's not saved. So anytime you do changes you're happy with, click the first green checkbox. These second two checkboxes are just for creating backup versions of your shader that work with older video cards. And I've never used them, and we won't be going over them. And this skull one is very interesting. It'll basically delete any nodes you don't have in use. So these three I'm not using up here at the top. So if I click them, it'll delete them. And I need to click the green checkbox again to save that. And also up here you can change the visual representation, visual mesh that the shader is on. Okay, so I will close this for now, and I'll go back to the material group. I'll save my package, and I'll create a new material instant constant, and we'll name this one shader nodes mat inst for material instance. And this window is a little different. It doesn't have all of the node displays. Instead, it's looking for something to control it, tell it what to do. So in this parent, I'm going to go into here and select the main material we made, and then go in here and click the green checkbox. So you can see it's exactly the way we left it. But you'll notice if we expand the scalar, you know, there's nothing in there, no controls in there, but the texture parameter and the vector parameters, these three values we had set up so we can change. So you have to click the checkbox in order to enable it. And then in here we can type in a value like 0 or 1 or 2. And now we can change that spec value. Color, same thing. And the good thing is it brings over the color picker as well. So we can change the color of this. And the good thing about a material instance is it's real time. You don't have to click any green checkboxes, and it'll update in your viewport real time. So you can make really fast changes. And for the diffuse, if I go into the generic browser, I can bring in another texture. And I can select it, go back in here, and I can change that texture. So sometimes you'll just want one good parent material that has a lot of the settings built in, but you can duplicate that out by using a material instance and just have certain parameters that you can alter to give different looks. And maybe, if you had cars, you would have different tints for those cars. That way you can just have one model and one parent material and several different looks. So material instances are very good for production. But if you're just doing something for fun and you want all the control you can get, then you probably won't use them as much. So I'll save the package. That's pretty much the controls we'll be using in the DVD. But to go into a couple more advanced nodes, we'll go back into the parent. And I'll show off an if node. And if nodes are really powerful. You can use them for a lot of different things. But I only really use it for swapping out different channels of a texture for a material instance. And just to help understand what an if does, basically it has two inputs, or it has two controlling inputs, and these things will choose one of these three outputs that you give. So you plug in three outputs, it spits out one based off these values. And I know that sounds a little confusing, but to show that, I'm going to go and import a texture that has three values, because these black and whites don't really have three values. And I'll bring in this channel texture, is what I call. And basically it's just it's all colorful like that, but basically it's just three different black and white textures packed into each of the different RGB channels. So we'll save those changes. Go back to the material parent, and we will choose the new texture. We'll go back to make sure it's selected. Go to the parameter 2D, and we'll just make a new parameter 2D. We'll call it stains. And we'll plug the R into the first value, the G, and the B. And we need to give this two controlling values. So really you only need one constant that's kind of like the standard value. And we'll put it 1. I'll show you why in a second. And we'll use a scalar parameter so we can talk to this externally for the top value. And we'll name this stain chooser. And we'll plug that into A. Okay, so what you see here is you have A and B. If A is greater than B, and you can see A is not greater than B, it's 0, and B is 1. So if A is less than B, then use this channel. And so the output, and what you see here, and we'll plug this into this add. Actually, we'll use a multiply so we can only get the darks. We don't want to brighten up everything. So we'll just throw in a multiply this if, plug in. You can see how we have that stain. So if we want A to equal B, then it'll use this other channel. So in order to do that, we just punch in 1. So now those values are the same, and it's going to use the green. It just changed that output. 3 inputs, 1 output. And if we make it greater than, which would be 2, it'll pick the other one. It doesn't have to be 0 or 2. It does have to be 1, so they're the same. But you could just put 1.1, and it's greater than 1, so it's going to work. But it's easy to remember just 0, 1, 2. And we'll save these changes by clicking the first green box. And we'll go back into the material instance, and you'll notice it has that stain. And when you go into the scalar parameters, there's a new stain chooser. So here we can 0, 1, and 2. And just with that one texture, we can get 3 different stain looks that are going onto our models. It's another good way to get a lot of different variations out of 1 or 2 textures or 1 controls. That's really useful. So we'll save that. We'll go back into our material, our parent material, and you can see how things can kind of get a little messy pretty fast. So it's good to try to organize this stuff. And one thing that can be useful, especially when someone else comes back over your work to see what you've done, to try to maybe optimize it or learn from it, it could be a good idea to use to separate these things, and also to kind of group them into a box. And to do that, you could just select a bunch of nodes. And the way I just drug select all those was I hold down Control and Alt. And when you hold down Control and Alt and drag, you can select a bunch at once. And you can hit in C, which basically brings open a comment box. And we can name that stains. And you'll see that if you hold down Control and drag it, those are all kind of grouped. And you can change the size of this box. And these things can be very useful, but I find myself guilty of not using them as much as I should. But it's really important for organization. Okay, so just a couple more nodes I want to go over. So this was the stains. I'm going to go ahead and delete them for now. And it's giving me an error because there's no longer an input in here. So I will delete the multiply. And the next thing I want to go over is how to do some pretty quick and simple reflections. And to do that, you have a camera vector. And basically, camera vector will take a texture and project it on its surface and make it look like it's reflecting it. And to do that, we can add we need a texture to project on here. So we'll go back and we'll get a texture sample. And we'll pick this channel texture. And you just have to plug it into its UVs. And now we need to either add or multiply this on top of this texture. So we will go ahead and multiply it. Another quick way to add a multiply is you can just hold down M and click, and it'll drop down a multiply. So if we plug these in and plug it into diffuse, you'll notice that it's giving me that error again. And the reason why it's giving me this error is because a camera vector, which basically is a is a reflection control, it's trying to give three different values, X, Y, and Z, in kind of like a world space value. But we need to flatten that because we only want it on a flat 2D texture. I think it's looking for a cube map, which has different ways of handling this information. Anyways, to simplify this so it'll actually work, we'll just need to use a component mask. And a component mask, what it's going to do is, you'll look down here, it has these checkboxes for RGBA, and basically you give it an input, which this one has a RGB or XYZ output, and we'll put it in here and we'll say let's just pick R and G and plug that into the texture sample. And the logic behind that is a texture is only 2D, so it's X and Y, There is no Z. And so when you limit it to RNG, it's only going to feed those values into the texture, and then it can understand it and project it on the surface. So you can see how it's just very smooth, very brute force projection, and it's kind of way overpowerful. So you may want to just pick a more subtle texture, maybe a skyline, and tune it to a value that looks appropriate. And the thing about a camera vector is it does not respect any kind of normal information you have, any normal map. And I'll go ahead and save these changes and show you exactly what I'm talking about. Go back to the generic browser, and we will import a normal map. So when you import a normal map, make sure you change this to the compression settings to normal map. And if you want to know why, I'll show you when it imports. Okay, now this is imported. Just to get on a small tangent, when you open up, double click the texture to look in here. When it imports this, the unpack max and min, the min has been changed to -1, so there's a much greater range of those values. And also it doesn't have sRGB check. So if you look at a normal texture, it has sRGB and it has a 0 min. So that's kind of the difference between a normal map and a regular texture. So we'll select this normal map. We'll go back into our parent shader. And I'll resize it again. And we'll go down to texture sample and drag one out. It should have brought in our normal, but because I didn't have it selected. Oh yeah, because I selected that. So I'll go back into my normal map, select it, choose it, and plug it into normal. And you'll notice it has this nice chunky normal map, but the reflection is kind of very smooth on the surface, very unrealistic. And sometimes you may want that, but if you actually want it to follow those normals, you would not want to use a camera vector. You would want to use a reflection vector, which is almost the exact same thing as a camera vector as far as I know, except it will respect the normals. So if I plug those in, you'll see that it crawls along that normal map instead of just projecting over the entire surface smoothly. And so reflection vector is usually a better choice. So you can see there's a difference. It's a pretty big difference. So you can try both and just see whatever looks the best. There's no hard and fast rules with that. Okay, so I'll go ahead and get rid of that reflection. And I'll delete these nodes. Save the changes. And the last node I want to go over is a bump offset. And a bump offset can be used to displace the pixels of a texture or other values based off of a height map or a value, any kind of value. And in this demonstration, we will go ahead and we'll copy and paste to get another version of that. And we will plug, and this height input is also looking for 8-bit alpha. You cannot use RGBA, just like with a linear interpolate. And so we will go ahead and plug this bump offset into the normal map. And if you look, you can see what it did. It displaced the white area from the black area. And let's see if I get rid of that. You could see where those brick lines are breaking up. It's displacing. It almost looks like one of those old 3D images where if you stare at it long enough, something comes out at you. It's exactly what it looks like to me. And if you select the bump offset, you do have some controls in here to push that displacement plane farther or closer, and how much what's the ratio of that. So in here, if I type in 10, you can see it gets a little out of control. So we'll go down to 0.5, put this one at 1. You can see I was totally distorting it. So I mean, it's real touchy, but you can play with those values. And we'll be using this node for a couple interesting effects later on. So I'll hold down Alt and break that, and then I'll select these and delete it. And that is pretty much it for an introduction over the different nodes that we'll be going over throughout the DVD. Hopefully a lot of these nodes make sense. I try to keep it very logical and a good foundation, so we can, when we get into more complex shaders, you can understand why something is doing what it's doing. And I'll try to explain it as I go as well. But that's it for this section, and we'll move on to making some cool shaders now. In this section, we're going to go over the window parallax material. And this material is actually not very complicated, and it performs really decent. And the effect that it gives is actually very useful. As you can see, you can fake the interior of a building without actually having to model it out. And this can give good impressions of lighting and meshes inside of that window. And we will open up the PSD. And in the PSD, you can see we have a diffuse, a normal, a mask, an emissive, and a specular. And we're going to pack the mask, emissive, and specular into one channel texture. And to create this, basically I just got a couple textures and I ran them through Crazy Bump to get the normal map. And I just put some purple over the windows so there wouldn't be all that detail on the glass. And I also darkened out the glass areas so the emissive will do all the work. And for the mask, I just quickly cut out where the glass would be. And then I just overlaid or multiplied some of the details in the glass too, so it just wouldn't be very hard-edged. This emissive is just a photo of an interior with a grunge map, and it's desaturated so we can pack into the channel texture. And the specular is very quick. It's just a modified version of the diffuse. Okay, so we'll go back to Unreal, and we'll go into the generic browser, and we'll go File, Import. Now we're just going to pick those three textures. I saved them out as targets. And we're going to make a new package and call it Shaders E3D. And we will put these in a Windows group. And we'll leave the name what the targets are. And it's a good habit to always check compression alpha unless you want an alpha, but most of the time you won't. Because when something has an alpha, it's double the memory. So we'll just leave compression alpha checked. And we'll hit OK. And for this one, we'll hit OK. And for the normal map, we'll change the compression to normal map and hit OK. Now we'll scroll down to our new package. And we'll save it, and we'll put it in packages. Now we're going to make a new material. And we will name this material Windows Matte. I'll resize the window. Okay, so we need to bring in these three textures. So I'll select the diffuse and I'll drag out a texture sample. I'll select the normal. And I'll plug them in. And I'll select the mask, the channel texture, and bring those in. So it's always good to name these something that makes sense. So I named this one Mask Emissive Spec, so I know the third one's going to be the spec. And it's pretty subtle because it's old concrete. And for this, we are going to add a tiled normal map. So let's click the green checkbox to save it. And we'll save this package. And we will import normal map tile. We'll change the compression to normal map. Compression to alpha. Save the package. And we'll select the normal map and drag out another texture sample node. Alright, so I want to blend these two normal maps. To do that, I'm going to add an add, and I want to add these together. But I want you to notice how it kind of diluted the power of the original normal map. And this is something I didn't go over on the old damaged pillar, but anytime you want to blend a normal map, especially a detail normal map, with an add, you need to remove the blue channel from the tiled normal map. And this is something you do in Photoshop whenever you overlay a normal map onto another one. And the same thing goes for here in the material editor. The blue channel in the tile will overpower the blue channel in the normal map and kill a lot of the depth. So we'll add a multiply, and we're going to multiply this with a constant 3 vector. And we're going to change R and a G to 1 and leave the B at 0. And then we'll plug that into B. And now you can see it's a pretty big difference. It actually makes both of the normal maps look much, much better. And we'll save these changes. And to try and stay organized, I will drag these off and put them in a group, a comment box. Okay. We also should tile that normal map. So to tile, we'll use a texture coordinate. And we'll tile it about 4 times. And you can see it is a lot better. You show a little before and after. Yep. Okay, now for the emissive in the glass. We had that emissive channel in here, if you remember. And that should be the second one. So if we plug that into the emissive, you can see it just overpowers the whole thing. Looks very bad. So we need to mask that out with the mask. And to do that, we will need a multiply. See, normally you would use a linear interpolate when you want to mask something. But when it comes to emissive only shows the bright pixels. And in the mask, if you notice, if I go back to Photoshop, you'll notice that these are the only bright pixels. So this is almost like a clever way to do a mask without actually having to do a linear interpolate. So this is going to be projected on the mesh itself, but since it's black, it's not going to show anything. So basically we just need to plug in the mask and also multiply the emissive and then plug that into the emissive. And now you can see how it's only showing where the windows are. It's very nice. Now, we also want to add some color so it looks like there's light in there, and that we can use a material instance to change that color and get a lot of different variations with the same texture. And there's no secret trick to that. It's just we'll use a multiply and a constant 3 vector. But instead of a constant 3 vector, we will use a vector parameter so we can instance this out. So we'll drag this back. We'll plug the vector parameter in A, and we will need to tint the interior. And so we can see something, we will pick a orangish color for now. And we'll put that one in B. And you can see I've chosen the wrong one, so we'll put that one into A and that one in there. Okay. So red is the mask, it goes into B, and green is the interior. But you can see it's kind of dull. So one thing about using this color picker is it really can only go to 0 and 1. And with emissive, sometimes you want to go above that because it'll really punch it through and make it glow a little bit better. So you can see around, you find the color around what you want. So let's pick something like that. And so we can just take this to like 1.5, 0.8, and maybe 0.2 or something. And you can see how it made it much brighter. So we can maybe even go more. I'll just go with 1.75. Okay, that looks pretty good. Okay, now for the parallax part. We'll save our changes. And for good habit, we will save the package. And for the parallax, we're going to use a bump offset. But instead of plugging a texture into the height, the only thing we really need to do is plug a constant in there. We'll put that at 1. And we'll plug it into this. But you'll notice we won't want to offset the mask. So we will need to copy this out, and supposedly it doesn't add any performance hits if you copy the exact same texture sample, or if it's pointing to the same texture node. So we will let this one go to the mask, and this is going to be static, and it's going to hold that mask, and the bump offset is going to, and as you can see, the spec as well, so we need to use this one for the spec. And the bump offset is going to separate the interior. So if you look in now, you can see how it's starting to separate. Instead of punching it positive, we'll try negative. Try like -2. You can see how it pushed it back, and that looks a lot better. So push it back even more. -3. So it really does push that interior texture farther and farther back. So you can experiment with numbers. Maybe try 10. And it really starts to get out of control pretty fast. So you can see that room looks a lot bigger. So anytime you do this, you probably want to use a negative number. That looks pretty good so far. But another thing we can do, it's optional, but another thing we can do is give a fake reflection on the glass so it doesn't look quite so see-through, and it can simulate a better spec on there. So to do that, we'd want to do it in the diffuse. That way that spec isn't showing, or that reflection isn't showing up in the dark areas. So we're going to do this in the diffuse, and this time we can't use the same trick, so we will have to use a linear interpolate. And we're going to put the mask into the alpha, and we're going to mask the diffuse along with camera vector. And I'm using a camera vector instead of a reflection vector because it's glass and it looks a little bit better if it's not bumpy at all. And we're going to need a component mask. Just a reminder, that's converting this to X and Y only for a 2D projection on a surface. And we will need a texture to project on there. And you can use the sky, you can use anything you want, but for this demonstration I'm just going to use I don't know, I'll just use a copy of my diffuse, see what that looks like real quick. Actually, I'll use the channel texture. I get more options. So I'll try the blue. Okay. So you immediately see now we have reflection. And it looks pretty good. But it may be a little too powerful. So one way we can tone it down is we can use a constant clamp. And let's see what happens if we try to blue. So yeah, I like the blue better, which the blue was spec. So reusing the spec is probably best, and we will put in the constant clamp You'll notice if we leave it by default, it's not going to change anything. But we want to clamp the max value, which should tone it down. So 0 will just completely remove it. And 0.1 leaves it in there. It's more subtle. And I like that. Looks pretty good. And that really pretty much is it. So that's all that is needed to create the parallax with the reflection, a tile normal map, a diffuse, normal, and a spec. And you can use this technique with any windows or any maybe even a car, or you can get creative with it. It's very simple. It's very cheap, as in it's only 66 instructions. And if we take out the reflection, didn't really save a whole lot. It saved 4 instructions. So if this is just going to be in some background buildings, you won't need the reflection, but this is if you have to get kind of close to it. And I will go ahead and show real quick how to make a material instance version of this, so we can have different colors like in the scene. So really quick, I'll use a material instance constants. Name it window matte inst blue. And we'll pick the parent. And in the vector parameter, it says none. I should have named it. It's a good habit to name your parameters. So really quick, I will go back and name the vector parameter color, or whatever you want to name it. And we need to reopen it. And this is going to have the same problem if we use this color picker. So you notice it didn't like that at all. So you notice how the values are all under 1. So we will need to punch that up. And you can see you can take it pretty high and it gets out of hand. We'll keep it around the same values as the other one. Alright, so you can see we have the 2 colors. And we're able to swap these out. This is BSP. So you could just swap the colors out by selecting the BSP and then selecting the texture you want. And you could have as many colors as you want. And you can see that with the bloom post effect, we'll turn the post effect off. The bloom will, be a lot bigger the higher that emissive vector parameter value we punch in. So if you punch it too high and you go to post process, you can see that it kind of blooms out even more. So there's a fine line. You want to keep it around the 1 value range. You could probably go a little higher like I did. But you don't go too high, because when you do your post process, it could bloom out too much. And that's pretty much it for this section. In this section, I'm going to go over the rubble piles, and I'm going to briefly go into Max and show you how I made this very simple modular rubble pile set and the shader that allows each of these to have an ambient occlusion and also tiled textures over the top. And you can see how they really help break up 90-degree angles, and they can blend in with the ground pretty well. But the ambient occlusion really helps settle some of the objects on the rubble pile. So I'll just jump into Max here, and I will open the rubble Max file. Okay, what we have here is these pieces. We have a pile of dirt, like a wooden board, a medium rock, large rock, and a piece of rebar. And so I just made these pieces, and the way I would normally do this is I would model each one of these pieces really high quality in Mudbox or ZBrush, and make these look really good, localized detail on themselves. And you know, rubble piles are meant to be cheap, but they're also used so much that you want them to look as good as possible. So let's imagine these are fully done models, and if we add an unwrap, you can see how each one of these objects is unwrapped, and if it would have its own normal map and tiled, or any kind of texture like a wood, stone, dirt. And now what you want to do with these few pieces, just like with Legos, is you want to go and make 3 piles out of those pieces. And the reason why I chose 3 piles, because you could pack each one of the ambient occlusions into a channel texture, and you won't have to worry about extra overhead. So 3 is the magic number here, and you wouldn't, even though you have an alpha channel, so you think you would have 4, it's not worth it to add a 4th channel, because memory-wise it's the same price of 2 textures without an alpha channel. So it's better just to keep it at 3. And all I did was place these pieces all around in 3 different orders, in 3 different piles. So they're unique as in the placement of the objects, but they're using the same pieces. And if I added unwrap on here, you can see if I go to the second UV channel, and this is something with Max 2008 that I just learned. If you go to the second UV channel, I mean, it looks like I don't have a second UV channel, but I do. And in my opinion, I think it's a really dumb move that they copy the first UV into the second one by default and override whatever UVs you had there. So in order to see your original second UVs, you have to go into the second UV channel and hit reset. And now it's going to show you your second UVs. And for a while I thought that it was just bugged out or I was going crazy, but I did a search on their forum and realized you have to reset it to get it back to what you have already done. Hopefully they fixed that in 2009, but we'll see. So on the second UV channel, you can see all I did was I copied the first UV. I just copied this to the second channel. And I just did a tools pack, and I just packed them with the 0 spacing. And it just, before these were overlaid, now they're not. So each piece has their own unique space. And this is going to be good for the ambient occlusion. And so I just baked an ambient occlusion for each pile. and you can see here how it gives really nice shadows, and you can see the before and after here, and we'll see it in Unreal. It's even a greater impact, I think, on the object settling on the surface. So now we will go into Photoshop and we'll check out what kind of textures we have. And here in Photoshop, I have a diffuse, and I have the UVs here so we can see what's going on. This is the first UV set. And you can see I have some rock, and I have some rock here, and I also blended in the ground dirt to the edges here. And I put some rebar colors in here, another rock here, and wood for the board. And the normal map, I just copied some of the rock normal map that I had generated from Crazy Bump, and I took the diffuse texture and made a wood as well. And the spec as well is very simple. And the ambient occlusion you will see is basically I just have these 3 channels. And this is what I generated out of Max. And I packed them into the R, the G, and the B. So that's pretty much it. So let's jump into Unreal and create the shader. So we'll go into the generic browser, and we will need to import file import. We'll need to import the rubble, ambient occlusion, diffuse, normal, and spec. And for the ambient occlusion, we'll just click compression to alpha and hit OK. For the diffuse, we'll hit OK. We'll choose normal, compression for normal. And we'll go back to default for spec. Now I'll save the package. And you probably noticed that I didn't give it its own group. So to do that real quick, I will hold down Control and select all of the textures I just imported, all 4. Right click, rename, and this is how you would move or make a new group. And the group, I'll change it to rubble. And I'll hit OK, and it'll remember, so I just gotta keep hitting OK. So you can see it made this new group. I'm also going to import the ASC files exported from Max for each rubble pile. And I'll have them in the rubble group. And I'll hit OK to all. And there they are. And now I need to make a new material. And we'll name it Rubble Matte. OK. So we will just drag in the diffuse. Spec. And the normal. Alright. It would be a lot better if we could see our rubble in here. So I'll do that real quick. So we will select a rubble, right click, and add the rubble static mesh actor. We will right click and go to static mesh properties, or you can hit F4. And we'll scroll to the bottom. And you can see where the static mesh name is. We just need to copy that. And we'll go back to the shader. I shouldn't have closed it. And we will go to the preview mesh and hit paste and hit enter. And now we could see what's going on in real time without having to hit the green checkbox every time to see the updates. So we'll just save obsessively. And okay, so we have diffuse, spec, and normal. So I will go ahead and add the ambient occlusion. And in this tutorial, I'm not going to go over making this instantable. I'm just going to make the choosing of the channels instantable. So we will go, and this is where we're going to use our if. So basically we want to multiply the diffuse and the ambient occlusion. But you'll notice it's all messed up because we have it on the second UV channel. So to change the UV channel for that, we just need to add a texture coordinate and change the coordinate index to 1. So you can see here exactly what it did. I'll just go back and forth. You see, it's just a little thing, but it adds so much realism. I love it. To use the if, so we can make this instanceable, we need to plug the RG and the B into the inputs. And we also, if you remember from the introduction, we also need a base constant of 1. And a scalar parameter in A. So if we plug this in, right now it's using, if A is less than B, it's going to be using R. But it looks like we need it to use, looks like since this is greater than that, if A is greater than B, it's going to use A. So 2 is A. So that makes sense. And we'll name this one AO ambient occlusion picker. And in the description, we can, if someone needs to come in and check it out, we can always put 0 equals B, 1 equals G, and 2 equals R. So in case someone needs to know, you can put that in there. And we'll go ahead and organize this a little bit. And you could see deep in that shadow, you can see the speck. And that doesn't look very realistic. So one quick trick to get rid of that is we will copy the multiply, and we will just also plug the same if into the spec. And basically that's just going to multiply that ambient occlusion on the spec as well, so we can get rid of those small highlights in the shadows. All right, and the last thing, it would be nice if we had some small details in there. Tile normal. This is important to me. This is just an optional step, and it's good to put it in, and it's easy to take it out later, especially if it's in the parent. So you can have these ambient occlusions all over the place, and you can just go back into the parent and remove it. if you have to find ways to increase performance. So we can go back to our tile normal map, add the multiply, add the constant 3 vector, so we can remove the blue channel, like we discussed in the window section. And we will just need to tile this probably about 5 times. So it's always good to do it before and after just to see what's going on. And it didn't add a whole lot. So another thing is you can actually take this beyond 1 and it'll increase the power of that normal map. But you need to be careful because it can cause artifacting, scintillation, where things will kind of sparkle a little bit. But it is an option, and sometimes you can use it. So if you take it like to 10, you can see how it's totally looks like it's corrupted. So we'll just try 2. And now we will see the before and after here. You can see it's actually adding a lot. Alright. And that really is it for the rubble pile. So I will organize this a little bit. And to bring up the comment box, just hit C. And there we go. So we will just save the package. Go into our static mesh editor. Find a cool looking angle. Click the eyeball so it updates that angle. And we will plug in the shader we just did. Now we will quickly add 2 material instances. We'll pick the parent. And we see the AO picker. Choose 1. And we will make sure this works. Okay, that looks good. And we'll just right click and duplicate that. And we'll just do it 03. And we'll change that one to 0. Looks good. So we have rubble 1. You can hold down S and click, and it'll place whatever static mesh is selected. We have rubble 2. And we have rubble 3. And you can see it does a pretty good job of blending in with the ground. Probably could be finessed a little bit. And that's it. And these things work really well. You could just shove them into each other a lot of times, and you can see I have them placed all over, and they break up straight lines, corners. They can give interesting, silhouettes. I even place them way in the background as long as you can never see the termination line. It just really just adds, like there's a collapsed building back there or something. You can press G to hide icons and stuff. And so right there, you could just see it adds a parallax. We have some depth of field, so you can see it's getting blurred out back there, and especially there with the wood sticking out, it really adds nice parallax and depth, and it just makes it seem like there's something going on back there. And that's pretty much it for the rubble pile, and that's all for this section. In this section, I'm going to show you how to make very simple dark stain decals that can be placed as static meshes on top of any surfaces. It can really help fake ambient occlusion or add dirt in corners or drips, break up tiles. Really a lot of use. Something that can really give that next level of grit to a scene. And you can see here, this is one. You see down there is one, like some water stains. You see how it's just right on the surface. And it's very, very simple, and it's very, very cheap. To get started, I'll show you a couple of the textures. Show you a couple different ways you can create these decals. And this first one, decal stains. These are all channel textures, and you can see here we have like a small drip, a larger stain, and some different levels of oil stains or whatever. And these are square. Also, an interesting thing you could do is a gradient. Sometimes you can just put in some fake ambient occlusion. To get the gradient to work, I had to end with a white pixel and also put a white pixel at the end here because it was causing a black seam. But if you get that problem, you could just add a line of white pixels at the bottom. So this would be a gradient up. This would be a gradient in the middle. Like if you wanted to put that behind a pipe against a wall, it could really look like that it's an ambient occlusion effect on that pipe. And there's nothing in B. And these drips are very good for corners. And you have a drip that fades off to nothing, a tileable drip, and a tileable water stain. Okay, so we'll go back into our generic browser, and we will import those three textures. We'll make a decals group. We'll choose compression no alpha, and this time we can hit OK to all. Okay. We'll save the package. And we're also going to need a mesh that we can use to place these textures on. So I do have one already made. And you can see it is nothing more than a plane, just two triangles. And it's mapped 1-to-1. It's very simple. It doesn't need to be rectangle, it could just be a square plane. And we will make our first material for this. So we'll drag out the stain. And in here, we will just plug the blue in, and then we'll pick the green. Pretty cool stain. Hit the green checkbox. And the only thing you need to do here is select the actual preview material node. And here you have blend modes and lighting models. And you have some more options in here, but basically here we're just going to change it from blend opaque to blend modulate. And it's hard to see it in here. You can see a little bit. But basically it's just going to take these pixels and modulate it against the background. So if the pixels are white, it's not going to show them. If the pixels are dark, the darker they get, the more it's going to blend with the pixels underneath it. So hopefully it picks up some of the color information, maybe some of the lighting information, and it's better than just having a single black texture with it opacity. So we will click the green box. We'll go to our mesh, and now we're going to pick that shader you can see here. And you can, if you want, go in here and give the ifs that we were using before to material instance this out. But it seems to me like it adds overhead for something so simple. And it's not that big a deal if you just duplicate it. Because these are more global decals, so you're not going to have a whole lot of them. And it wouldn't be so bad to go in and if you had to make some changes. And if you don't click the green box and close it, you can just hit yes. So I normally just make a new material for these because it keeps them pretty simple, pretty cheap. The way you would just want one mesh, and the way you do it is you would just place the mesh. We'll just place it here. Hold down S and click. We'll click G so we can see our icons. And we'll change to rotate. And we'll rotate this down. We'll tap spacebar to change our move tool. And you can see here, it's just a stain. And you can put this anywhere to break up. Press G. You can put this anywhere to break up tiling or give. You can put these under static vehicles or under any kind of props to give it like almost like a dirty ambient occlusion look. And we can do the same thing to drips. We'll just quickly make 3 of these. We'll save. We'll hold down Alt. And to keep this same mesh, we'll hit F4. We'll go down to the material slot, click the green plus so we can add a new material slot, and then overwrite that material with this new one. And you can see it had chose the drip one. And since the drip one is a rectangular texture, we can scale it non-uniform. And then rotate it up and then over. And you can see we can place it dripping down give it that dirty look. And the same thing could be for if you wanted to use the one that goes halfway and stops. Let's see, we'll try that one. We'll hide this, select the original, and go down to material. And you can see how it kind of terminates. That way you don't have to have an infinite line to make the tiling stop. You can just have it stop there. But the other one had a straight line. And really quick, I'll duplicate this again. Name it gradient. And we'll choose the gradient. And you can see here, if we override it with those, you can see how this gives it a gradient in the center. So if we had a pipe there, it would be like the shadow of the pipe. And you can non-uniform scale it to be whatever size you want. And also, if we pick the other gradient, you can see how it's just a single gradient. So this can be really good to fake ambient occlusion on large surfaces. And you can also, if you wanted, instead of using modulate, you could use additive. And you would have to have a texture the way you'd want it. Maybe if it was some kind of light source, you wanted to have additive. And you maybe even give it a little color. You can see how that additive really brightens up that surface and tries to retain some of the information. So sometimes you may want this, if you're in a restaurant, you want, oval light marks on the wall or something like that. You can experiment with it. But for this, I'm just going to use modulate. And that is pretty much it for decals, mesh decals. They are very, very useful, very cheap. Modulate is really good because it can pick up the information underneath it. I will show you one other thing really quick. If you don't want it to be modulate, let me go back and we use this. We'll change this to world, and we'll go back to this decal. And I will show you that you don't have to use modulate. See, if you look, this one was 19 instructions. Another way you could do it is, instead of using modulate, you could use, you can go unlit, and you can change it to, we'll click the green box here. You can see it kind of kills the modulate. So we hit F4, and we'll turn off, you want to turn off cast shadows and all these, because it doesn't need to, the mesh will try to cast shadows on itself. And we don't want that, because it'll basically look like that. And So we need to change it to translucent, unlit, and we will put this down in opacity, and you'll notice that it needs the exact opposite information as modulate. So for this, I will just throw in a 1-. But if you do decide to use this, I would invert it in Photoshop. And you can see how you really can't tell much of a difference. Sometimes you might be able to. And but the cool thing is, you notice it's only 3 instructions. It's very, very cheap, and I don't really know why the other one is cheaper. In earlier versions of Unreal that I've used, the modulate was only 3 or 4 instructions, but in Unreal Tournament 3 it says 19 instructions. So, I don't know, maybe if you work at a studio, you can ask a programmer which, if it's really that much more expensive. If you want to be safe, just use the opacity. If it doesn't look quite as good as you want, you can go back to modulate. I think they're both very well. I personally would like to stick with modulate if possible and additive. And that covers decal meshes in Unreal Editor 3. In this section, we're going to go through the process of creating the material on this wall. And as you can see, it's just a flat BSP wall. Yet it looks really displaced. And the bricks look like they're actually modeled. Also, you can see how the brick repeats, but then there are sections where the walls eat away at the concrete underneath it. The shader is pretty cool. It goes through the process of blending 2 textures and displacing the bricks. So first thing we'll do is check out the PSD. And in here what we have is a tileable diffuse brick. And likewise, we also have a tileable normal. This was actually just generated out of Crazy Bump. And then in the channel texture, we have a spec, displacement, and a mask, tileable mask. Actually, these are all tileable. And you can see in the channels, spec, displace, mask. We'll close that. And also, it's blended with another texture. It's a rock. So we have the rock normal and then the rock diffuse. And both tile are very chunky. Also generated with Crazy Bump, and this could have looked better if it was done in Mudbox or ZBrush, but it's perfect for this example to see what you can squeeze out of these few textures. Okay, so we'll go into our generic browser and we need to import all of these textures. So we'll import the bricks, diffuse, spec. We'll do the normal separate. Brick, diffuse, brick, spec, rock, diffuse, and that's pretty much it. And we'll hit deferred compression and compressional alpha. And we'll just hit OK to all. And it'll go much faster because I used deferred compression. And once again, I forgot to put it in its own group, so I'll select that, these 3 textures, and rename them to a bricks group. And I'll import the 2 normal maps. Change it to normal map, compressional alpha, and defer compression, OK to all. So that basically brings things in really fast, but it defers the compression, which takes a long time until you hit save. So we'll go ahead and hit save now, and it'll compress all of these. And we'll create a new material. We'll name it Bricks Matte. I'll resize it. And I'll bring in the diffuse. Channel texture. And the normal map. So you can already see that looks good, but when you start looking at it, you can tell it's flat. The displacement we do is going to add a lot. So all we have here is diffuse, spec, normal. We'll hit the green checkbox. We will go ahead here and displace it. So to do that, we need a bump offset. And we're going to use, the name of this was spec displace mask, so we're going to put the displace and the height. And we just need to plug these into the normal, diffuse, and normal. So if you can see it here, so I'll break it real quick, holding down Alt. So you can see what it did. So this looks kind of flat, and then we'll plug these in, and it really makes it look like you're looking down, up, like it's starting to block the bricks underneath it. Really gives it that chunk. And just for our testing here, we will go ahead and add a texture coordinate, and we will tile this so we can see it better. But then we'll just delete that whenever we're done. So we'll go ahead and tile it even more. So that's looking really nice. And while we're here, we will quickly blend a normal map. And since I've already done this before, I will just open up another shader, go down to where I've done that, hold Control Alt, and drag over those nodes. Hit Control C to copy, and then go back in here and hit Control V to paste. And that's a quick way to copy nodes from one to the other. And we still need an add. So since we tiled this one a lot, we're definitely going to need to tile this one even more. But we need to remember it so we can take it back down. And we can increase this if we want. So you see the before and the after. It really adds that extra level of fine detail. Okay, so we have a good normal map with a tiled normal map on top of it, a spec, and also this spec should be tiling the same as this bump offset. So we'll plug this into there. So that tile could be sharing with the same amount. So the next thing we need to do is blend in the rock. So for blending and diffuse, we will use a linear interpolate again. Oh yeah, I was going to say that this pink warning is basically saying that we have pixels in this texture running into the bump offset, and then it's going from the bump offset into the pixels of another texture. So this can be quite expensive, as in it has to calculate all of these pixels and then all of these pixels. You can't use this all over the place, but for some areas you will be able to use this, maybe in cutscenes or hallways or areas where there's not a lot of action, maybe. And who knows, the programmer will be able to dictate if that's too much or not. Even though the instructions didn't go up, it can be a little deceiving, but it is extra calculations that instructions don't necessarily represent. But I've used this in production and it's shipped, so it can be done. It just needs to be used sparingly. So in the linear interpolate, now we're going to bring in the rock textures. We'll bring in the rock diffuse. And then we'll use the mask. And you can see it breaks up the tile pretty nice. But what really is going to break up this tile even better is going to be the normal map. So we'll copy and paste the linear interpolate. We'll plug this add into A, and we'll bring in the rock normal, and we'll plug that into B. Put the mask in, plug that to normal. And you can see there, it breaks up the brick normal tile very nice. But it's a little hard to tell with the way that it's tiling. So we are going to want to tile this mask much larger than everything else. So we'll copy and paste the channel texture. And things are getting a little unorganized, so we will quickly organize this a little bit better. We will go ahead and put the diffuse in a group in comic box. We will put all these normals in a comment box. And we will plug in the mask. Now this mask doesn't have a tile, so you can see it's much larger tiling frequency than everything else. And we'll copy this texture coordinate and we'll change the tile to be smaller. So you can still see the tile, but it depends on how large your surface is, on how much you want that to tile. So basically the best way to adjust this setting is actually going to have to be in the editor on a surface, because it's hard to determine what the scale of this actually is. So to do that, we're going to go into one of these walls. We'll go ahead and pick this one. And we'll assign this new shader to that wall. We'll save the package first. And you can see how it's tiled like crazy. We need to go ahead and get rid of this tile that we had going on. And remember, we also tiled the normal tile, so we'll take that back down to 4. And for the mask, we'll take it down to like 0.2, something very large, with the green checkbox. And you'll see now it looks a lot more realistic. That is because we're editing this in the actual scene, and it can get really complicated in changing these settings. So it's better to do it in the actual scene. And we'll just move this off. So that's the bump offset. This is the mask. And that's the normal. And that really is it for the wall. So to recap, we have a brick, we have rock, we have the normal map brick and the normal map rock, and then we have a tile normal on top of the brick. But really, we would want the tile normal to be on top of everything. So let's go ahead and put the brick here in this lerp, and then put the lerp into the add. That way the tile normal map, you can see this is a tile normal map without the blue getting plugged into what would be these two blended together. So basically the tile normal is now going to be on the brick and the rock. And that really is what we want. We just want some kind of global granular detail on everything. And we'll save that. Now we'll check it out in our scene, and it looks really good. And that's all that's involved in making a really nice chunky brick material. In this section, I'm going to go through creating this ground texture that basically blends between two different brightnesses of the dirt texture and incorporates the rock texture using the bricks and also a dirt normal map. And I'll just show the PSD really quick. So nothing special, just a tileable dirt, tileable normal map, and a channel texture that has a speck and a mask. And this is the same mask that's used on the brick wall, but it's better to have it in its own texture sample. That way there's only one texture lookup, is what it's called. The fewer textures that the video card has to look up for a shader, the much cheaper it is. Now, if you wanted to fill these slots with something else, fine, but even though it already exists in the brick, go ahead and put it in the dirt as well if you want to use it. So we'll go into the generic browser and import the dirt diffused, dirt normal, and dirt speck mask. Dirt diffuse, we'll go compressional alpha for compression. Change this to normal map and change it back to default. And once again, I forgot to put these in their own group, so I'll do that real quick. And I'll save. Okay, now we'll make a new material. We'll name it Dirt Mat. We'll start off with the dirt. We'll drag out a texture sample. And we'll see what's going on here. Pretty dirt texture. We'll bring out the normal. And the channel texture. And the first one was speck mask, so we'll plug that in. So this is a basic shader, but we want to blend based off of that mask. Instead of using two different diffuses, in this case, we will try just reusing the same dirt, but darkening it up a little bit. So I'll hit copy paste to get another version of this. And I'll drag out a multiply. Or just hold down M and click. And we'll drop a constant. You can do that by holding down 1 and clicking. And we'll change this to 0.5, which should darken the texture. Let's test it out. Yep. Now we will just blend based off the mask in here. So we need a linear interpolate. And the mask. Looks good. That will really break up the tile, especially on a ground, because usually grounds cover a large area and tend to tile a lot. It'd also be good if we could blend the normal map, but in this case, it's not going to work to reuse the same normal map. You could if you had to, just tile them at different frequencies. But in this case, I'm going to reuse the rock normal. And we'll use another linear interpolate. And we'll use the same mask. Alright. So in this case, I think it would look better if the dirt was darker than the chunky rock. If you wanted to do that, you could simply use the same mask, but we'll just use a 1-, and plug that in. That will basically just invert whatever's dark. Another way you might want to do that is leave that the same, but swap these. So yeah, you can see that actually does the same thing pretty much. If you want to see, yep, I'll drag that back over. So that's another way you can do it, is you can just swap the A and B channels, which should swap what gets dark. So we'll delete the 1-. There's no reason to have extra nodes that we don't need. It's just extra overhead. And usually on a large surface like this, you would want to tile these a lot bigger. So we'll drag out the texture coordinate on the mask, and like the brick wall, we'll give it a much larger tile. And also for the chunky normal, usually you'd want something with large details like that. Tile a lot less, so we'll do it at 0.5. Click the green checkbox, and we'll see here we have a linear interpolate blending a large rock normal map and a dirt normal map. We'll drag these here. We have just a regular spec, which if you wanted to, you could give different specs, but in this case it's not necessary. And then we have the two dirt textures, one darkened and one regular, blending with the same mask used on the normal map. So this is a technique that I use for grounds. I try to see what you can get away with. Maybe you don't need 2 speculars, 1 can be fine. Another thing you could try is just reusing the same diffuse for a speck, and you could put in your scene in different lighting situations and see if it holds up. And if it does, then you've saved yourself some instructions. So we'll plug the speck back into the speck. We'll keep it pretty subtle, and we'll hit apply. And that is pretty much it for the tiled ground. Very simple. Another thing we would do here is add a detail normal on top of all the slurp, like we did with the wall, if you feel that's necessary. And if we were going to do that, the quickest way would be just to go down here, select all the nodes, copy, paste, and we'll just plug that in there. And it's missing the input, so we'll just plug that in. And we'll see that before it looked like this, and after, just added those small details. Looks like I accidentally pasted it twice, so I'll select these by holding Control-Alt-Drag to select them all, then delete. Hit the green checkbox. And since this tile normal is pretty much going to be on everything, the only overhead it really is a couple instructions and another texture lookup. But as for texture memory, it doesn't add anything. And that's pretty much it for this. We'll go ahead and save and move on to the next shader. In this section, I'd like to quickly go over how to give some surfaces maybe an iridescent look, and also controlling the speck fall off or glossiness. And we'll go into Photoshop and check out the PSD. And this one uses nothing fancy. It's a diffuse, normal, and a speck. So we'll go to the generic browser and import diffuse, normal, and speck. The same way we've been doing before. We'll save it. Okay. And now we'll make a new material. And we'll drag in the diffuse. Normal. And the speck. So first thing here is I want to drop in a constant. And I'll put in 15 and plug into the spec power. And 15 is pretty much the default setting for that. But you'll notice if I take off the normal right here, if I set this to 1, it made the fall off of that speck highlight really big. So if I put it like 5, you can see how it's getting smaller. 15 is default, and go to like 50 or something, it's even smaller. And that's how you would control that. And in this case, we may leave it kind of high. 55 is fine. To show the iridescent reflection, basically that's all it really is a reflection. Sometimes you get a lot of different looks out of using the same nodes. And this time you would want it to follow the normals. So we'll use a reflection vector. And we also need the component mask. So we can force it to be X and Y. And we need a texture. And you can experiment with things that already exist. One thing that I stumbled across was using a channel texture actually as a reflection. So if we try to multiply that with the diffuse, you'll notice that it's way too dark. So we will invert it and see what that looks like. And it's ideally I would make my own texture in Photoshop, but here I'm just looking how to reuse stuff I have. And you can experiment with some of the other textures. Sometimes you'll get lucky. You get some really interesting chrome looks. Let's see. It's fun to just experiment. Some of the different effects you can get just by swapping out different textures. And you could also try and add as well. But for now, I'm going to just stick with inverting the window channel texture. And it looks kind of interesting on the surface. So let's check it out in here. You can see based off your angle, makes it look oily on the surface. And sometimes this effect can give some interesting results without having to create new texture for the reflection or just having a basic shader. And that's pretty much it. It's very simple and just showing you that you can experiment with using textures for different purposes and get interesting outputs.